Hello friends, myself Spindar Kumar. I'm taking Power Electronics for the third year double E students. Today we will discuss about the DC to DC converter. In the previous lecture we will discuss about the operation of the choppers. Now we will discuss about the principle, and in the previous lecture we will discuss about the types of choppers and their classification and what parameter we are focusing on classifying about the choppers. Now we will discuss about the principle of chopper operation. A switch is connected in series with a DC voltage source and load. The switch can be a power transistor, an SCR, or a GTO. Ideal switch will offer zero resistance, infinite resistance, and instantaneous switching. No lag will be there. So that will be the main objective, that there is no lagging will be there, and the on-off time will be very fast. The switching can be turned on and turned off with the help of triggering circuit and commutating circuit respectively. It can be turned on or turned off as desired at very high frequency. The objective of this one, that the turn on and turn off will be performing because the supply will be a DC one. So input is a DC and we are required a fixed output at the output side. So that for that moment we are required the firing circuit and the commutating circuit. It can be turned on or turned off as desired at very high frequency. During the T-on period, chopper is in on condition and load voltage is equal to source voltage Vs. During the T-off period, chopper is off condition, load current flows through the freewheeling diode FT. As a result, the load terminals are short-circuited by freewheeling diode FD, thus the load voltage is zero during T-off period. In this manner, a chopped DC voltage is produced across the load terminals. From the time period, if we are saying that the T equal to T on plus T off, it is clear that the load voltage depends on two factors. First, the supply voltage. Second, the duty cycle of the chopper. Since the supply voltage is constant, load voltage is governed by the duty cycle of the chopper. In other words, we can say that the load voltage is dependent on two factors, T on and T off. Hence, it is concluded that the average load voltage can be controlled by varying the value of T on and of T off in the following two ways. Varying T on and keeping the periodic time T constant. This is called constant frequency system. Variable frequency system, that is keeping either T on constant and varying T off, or keeping T off constant and varying T on. So according to the equation, we can say that the V output equal to T on upon T on plus T off upon Vs, or T on upon total T into Vs, or alpha times Vs, where alpha equal to T on upon T, where alpha is the duty cycle, where T equal to T on plus T off, chopper frequency is the F equal to 1 upon T. For finding the effective RMS output voltage, V output RMS equal to VI square T on upon capital T means total T. VI in the root of T on upon T. So we can get it that the V input square root of D. D is the duty cycle of the system. The representation of the chopper circuit during different phases are shown below. That over here you are finding that there is normally the three components are aligned over here. One will be the switches, it will be indicated by the SW. Another will be the inductance, which will give you a constant smooth output. Another one parameter is the freewheeling diode, and this will be your load. So this load may be of the resistive type or may be of the inductive type. So for the first operation, whenever we are saying that this switch is on, if this switch is on, then automatically the freewheeling diode it will be open circuited because the current is flowing in the right direction, and it will be moving from the supply to switch, then inductance, then load, then again return back to the supply. So freewheeling diode is not operating, so we can indicate as a open circuited. Second case, whenever the switch is off, if the switch is off, the whatever energy will be stored within the inductance, that will be circulated through the load, freewheeling diode, and return back to the inductance. So inductance is working as a source for this one. So this is a symbolical diagram where we are indicated as a two-port type network, where the two point will be as an input and two-point will be as an output load. So it can be represented like this, where center box or the rectangular part will be work as a chopper. Step downward buck chopper, output voltage is less than input voltage. The thermistor in the circuit acts as a switch. When thermistor is on, the supply voltage appears across the load. When thermistor is off, the voltage across the load will be zero. Practical arrangement includes an inductor and a diode which are used to eliminate current pulsations, providing a smooth DC current. With S closed, D is off and it remains off as long as S is on. The input current builds up exponentially and flows through L and low. V output equals to the V input. With S off or open, the current through L decays to zero. This causes an inductive voltage with opposite polarity across the inductance. Load voltage forward biases due to the diode D. Current flows through L, load and D. This arrangement permits the use of simple filter inductance L to provide a satisfactorily smooth DC load current. With higher switching frequency, smaller inductance is sufficient to get out desired output. So this is another circuit which will indicate that when the circuit of the buck converter is operating, when the diode favoring diode is disconnected while the switch is on, while the switch is off, then the automatically the inductance, the energy stored within the inductance, it will be discharged to the freewheeling diode. The output voltage is equal to the input voltage when the switch is on and D is reverse bias. Diode current is same as the load current during the off time. During T on, output current is same as the input current. So that will indicate over this side that there is a T on, we are getting the output voltage. When the T off, there is no signal will be available. Right? Then similarly the output current, it will be fluctuating over their side. It will be increased during the charging and it will be decreased during the discharging. So in charging and discharging we will continue for the voltage. Step down buck chopper continues below the continuous current. We are finding that the average value of inductor current is IL equal to I max plus to I min upon 2. Means it will be the average maximum plus minimum. So I output equal to V output upon R. Again we can say that the VL equal to I V naught into S times DI naught upon dt, or DI naught by dt equal to V naught upon IL. V naught upon L. So change in current I naught equal to VL upon L del T. Switch open, then peak to peak ripple current will be available. So I peak to peak equal to del of I naught, I max minus I min equal to V naught upon L into TO. Similarly, for the maximum current, we are finding that the V output upon R equal to plus V output upon 2L into TO. So V output upon R minus V output upon 2L into TL. So ID will be the I of time into T naught upon T, or I naught equal to I upon D, I upon D. So D is stand for the duty cycle of the system. Step down chopper continuous current as elements are ideal. DC power drawn from source must equal to DC power absorbed by load. So P output equal to PI will be equal to V output upon V output into I output equal to V input into input voltage into I. So this is the same kind of waveform we are getting for the output current, input current, output voltage, input voltage, current flowing through the diode, current input current, output current, and the load voltage. So this will be the waveform which will be indicated over here, through which we can find out that what will be the kind of nature of the circuit when during the loading conditions and thus off and on situation of the. Next will be the step down buck chopper discontinuous current. For low value of D with low L, input load current decreases and may fall to zero during T off time. It again builds up with T on and hence it is called discontinuous current. Under this side, you are finding that the for a specific period, whenever we are saying about this part, we are finding there is no current is flowing. So no output current will be available to the output side. So we are avoid to use this kind of arrangement where the discontinuous operation is moving on. So there is two conditions are applicable. One is this one, and the another is the dotted part. Dotted part will be indicated that there is for the some time there is no current is flowing at the output side, while the D-on is unable to operate itself just to give the output current at this moment. Step down chopper discontinuous current. This mode is undesirable and is avoided by proper selection of chopping frequency and inductance. The minimum value of inductance for continuous current mode is ensured by setting the I minimum equal to 0. So I min equal to 0 means V output upon R equal to V output upon R into T of. So V output upon R equal to T of into V output upon 2L. So 2L equal to T of upon R. So the value of the inductance which we have to set up, it must be T of by 2 into R just to maintain a continuous current from the discontinuous circuit. And this will be the end of the lecture. Thank you.